Welcome to The Explainer. Every single time you send an email or stream a video, you're kicking off this invisible, high-speed journey for your data across the globe. Today, we're going to pull back the curtain on the secret rules that make it all possible.
Okay, just for a second, imagine this. What if your iPhone couldn't message a Samsung, or your Dell laptop couldn't even see an HP on the same network? It would be total chaos, right? Well, believe it or not, in the early days of networking, that's pretty much the digital mess we were heading towards.
So, to stop this digital Tower of Babel from happening, where no device could understand any other, engineers had a huge problem on their hands. They had to figure out a way to create a universal set of rules, a common language that every single device could speak, no matter who built it.
And that is where protocols come in. Think of these rules as the secret handshake of the internet. They're the agreed-upon instructions that let any device, from any company, anywhere on Earth, talk to each other without a problem.
Now look, there are a ton of different protocols out there, but for what we're talking about today, your data's journey, the big one, the one you really need to know, is a two-part system called TCP/IP. This thing is basically the engine that runs the modern internet.
So, when you boil it all down, a protocol is really just a shared agreement. It's the rulebook that every single tech company agrees to play by. It guarantees that when one computer sends something, any other computer can catch it and know exactly what it is.
Okay, so TCP/IP, they're a team. Think of TCP as the slicer. Its whole job is to take a big chunk of data, say a photo you're posting, and just chop it up into these small, manageable, numbered pieces called packets. Then its partner, IP, steps in. IP is the addresser. It takes each one of those little packets and slaps a digital mailing label on it. With your address and your friend's address.
All right, so our data is sliced, it's addressed, it's ready to go. But here's the cool part. It doesn't just travel in a straight line. Nope. Instead, it embarks on this wild journey across the web using a process called packet switching.
Let's make this real. Say you're sending a big video file to your friend. That file is massive. It's way too big to send in one piece. Trying to do that would be like trying to shove a whole car through a tiny mail slot. It's just not going to work.
So this is where that whole process really kicks into high gear. First, TCP jumps in and splits that huge video into maybe thousands of tiny packets. Then, IP gives every single one an address and a sequence number, kind of like saying this is piece 1 of 5,000. Then bam, all those packets are just set out onto the network. At the other end, the receiving computer grabs them and uses those sequence numbers to put the whole video back together, just like assembling a giant jigsaw puzzle.
But wait, here's what's truly amazing. The packets don't stick together. Each one is on its own mission. It's like thousands of tiny cars all starting a race at the same time, heading for the same finish line, but each one takes a completely different road to find the absolute fastest way there. And that simple, brilliant idea, that's what makes the internet so unbelievably tough and reliable.
So this whole system of protocols and packets is, it's genius. It's efficient, it's resilient, but what happens when your network, the one you built for maybe 10 people, suddenly has to handle 100 or even 1,000?
Yeah, this is a classic problem for anyone who manages a network. Everything's running great, just humming along, and then boom, your boss comes in and says you need to add 100 more devices. This challenge has a name. It's called scalability, and trust me, it is a huge deal.
Right away, when you try to scale up, you run into 3 major headaches. First up, security. Every new device you add is another potential backdoor for a hacker. Then there's storage. All these new users are creating more and more data, and you gotta put it somewhere, right? And finally, accessibility. How in the world do you keep the network from slowing to a crawl for everyone when 100 new people just started using it?
So, what's the answer? How do giants like Google or Netflix handle billions of users without the whole thing just collapsing? Well, thankfully, we've come up with some seriously powerful tools to manage all this complexity.
The first big game changer is something you've definitely heard of: cloud computing. So instead of buying and setting up endless rows of their own physical servers, companies can just rent almost infinite storage and power from services like Amazon Web Services or Google Cloud. This pretty much solves the storage problem overnight. And the best part? They can scale up or down whenever they need to. Second, you've got the Network Operating System, or NOS for short. This thing is literally the network's air traffic controller.
It's this powerful piece of software running on the main servers, and it manages every single user. It controls who gets to see which files, and it directs all that data traffic to make sure there are no digital traffic jams. It keeps everything flowing smoothly.
And number 3, there's network utility software. You can think of this as the network's janitors, security guards, and maintenance crew all rolled into one. These are the programs that are always running in the background, doing things like scanning for viruses, backing up important data automatically, and encrypting information to keep it locked down and safe.
So here's the crucial thing to remember. None of this stuff works alone. The protocols like TCP/IP, the whole packet switching process, and all these new ways to scale, they all have to work together. They're a team, and they operate in perfect harmony.
And that's really the key takeaway here. All of these systems working together create this incredibly tough, invisible architecture. It's the foundation for everything you do online. Working, learning, watching movies. And it's an architecture that works so well, you probably never even think about it.
So let me leave you with this. The next time you hit play on a movie, just for a second, try to picture it. Thousands of tiny packets of data, each one holding just a single frame of that movie, racing across the world from all different directions, all to reassemble perfectly on your screen in less than a second. It's just a mind-blowing symphony of organized chaos, and it's happening all the time, just for you.